VLSos here. This is a video lesson, slope from points on a graph. We've been talking about this idea of slope, the measure of a line's incline. So we can find the slope between 2 points when those points are on a line. And if we find the slope between 2 points on a line, then we'll find the slope for all of the points on the line. We'll find the slope of the line itself. We're going to start with an example. I have a line graphed, and I have 2 points highlighted. I'm going to find the slope between these 2 points. The 2 points that are highlighted are easy to work with because they're at locations where the coordinates are very easy numbers to find. This point has coordinates of 2, 4. X is 2, y is 4, the coordinates of that point. This point here has coordinates x equals 4, y equals 7. Easy coordinates to work with. The slope between these 2 points can be calculated as the vertical change divided by the horizontal change. What do we mean by vertical change and horizontal change? Well, imagine starting at 1 point and changing our position to get to the other point. Well, we're going to go up and to the right. But how much do we go up and how much do we go to the right to go from 1 point to the other? And we can separate those 2 quantities or those 2 measurements. We can focus only on the vertical change. The vertical change is going to be the amount of change when we start at 4 and move to 7 vertically. The y information is our vertical coordinates. So if we start at 4 and move up to 7, we must have changed by 3. We could draw a triangle to visualize the distances that we need to change. This leg of the triangle that was drawn isolates where we can see just the amount of vertical change. We had to start down here at a y value of 4 and go up by 3 to get to 7. The measure of this line is the vertical change. Vertical change is kind of a complicated term. We have a simpler term that means the same thing as vertical change, the word rise. From 4, we had to rise by 3 to get to 7. So the rise, in this case, is equal to 3. Horizontal change is how much we have to change just horizontally to go from this point to this other. And in our triangle, this leg, this distance, represents just the horizontal amount of change. It's the change in the x information. So the coordinates of this point started with an x value of 2. And then I moved to the coordinates, the x value of this point has an x value of 4. So how much did I have to change to go from 2 to 4? Horizontal change, in this case, is 2, the measure of the distance of this line. Horizontal change is also kind of a cumbersome term. We have a simpler term that means the same thing as horizontal change. The word run means the same thing. And in this case, starting at 2, we had to run by 2 to get to 4. So the horizontal change, or the run, in this case is equal to 2. If we have different terms for vertical change and horizontal change, we can also express this fraction, this quotient, this division problem as the word for vertical change, rise, divided by the word for horizontal change, run. This line here has a rise of 3 and a run of 2. So its slope is that rise of 3 divided by the run of 2. And we can remember that this is a slope. Some of you familiar with the concept and the calculation of slope already may know that there is an equation to take the coordinates of these points and then calculate the slope directly. That's the topic of another lesson in the future.